Hello guys, welcome to answer key for ECE paper. So GATE examination is over and we have prepared the answer key and detailed solution for electronics and communication branch right now. So I'll be giving you quickly all the answer keys so that you can cross check your answers and calculate how much marks that you guys are getting, and let us know the any difficulty that you are facing. Soon we will send you the detailed solution as well. So the first question is, I cannot support this proposal. See, you are saying you cannot support this proposal. Why? Because my something will not permit. What is that that will not permit it? So it is something like that conscience, right? Like the thing that you are actually not willing to do because you do not know that whether it is wrong or right, right? So it is conscience, option C. Next is courts. We have to find out what is the word parliament, legislature. So parliament is something like a place where the assembly sits, the people sits. So same way court is a place where who sits, who decides the law. So that is basically judiciary. Judiciary is going to decide what should be the I mean result, right? So it is not executive or government or legal, it is judiciary, option A. Going to the third question, what is the smallest number with distinct disease, right? Distinct digits are whose digits add up to 45. So see, the smallest number that you can see here is 99999, but the thing is you will see all the digits are repeating, okay? So you have to leave this guy. Even this 555 is there, so this will also be not. As you can see, B and C options are actually correct. However, B is bigger than C. Why? Because 6 is earlier than 7, right? So my option will be C. C is smaller than B, okay? Because 6 is there and here it is 7, so 7000 is more than 6000, okay? So C option is the smallest and all the digits are distinct as well, okay? Like alag alag digits hain sare. Okay. In a class we have 100 students, so there are 30 students who neither likes romantic movies nor comedy. So I have solved it, I will give you the detailed solution. This can be very easily solved by a Venn diagram. So you will get the solution. 60 students are there who are liking the romantic movies, okay? So coming to the next question, question number 5. So how many rectangles that are present in the figure? It is very quickly like 1, 2, 3, 4, then put together 5, put together 6, then put together 7, put together 8, and then what? The complete one is 9 because this is another a rectangle, and the bigger one is 10, okay? So this is the thing that you can very easily find out. So total is 10, option is C for question number 5. Question number 6. Forest land is a planet inhabited by different kinds of creatures. So see, this has little bit of confusion. What it is saying is all the creatures with claws are animals. Yes, that is right, because he is saying that among the creatures it is populated by animals, all of whom are ferocious, okay? And it is also saying that the creatures that have claws and some do not, all creatures that have claws are ferocious. So if the creatures have claws, they are ferocious, and if they are animals, they are ferocious, okay? So it means all the creatures which have claws are animals, or even D is very similar to that. Some ferocious creatures are creatures with claws, okay? So all the creatures are not animals. It means some creatures are there who are ferocious, have claws, okay? So according to me, the option can be A, okay? But you can think of D as well, okay? So question number 7, which of the following option represents the graph? The graph is given like this. So as you can see, the graph is even function, okay? So this if you go by option D is x 2 to the power 2 to the power minus x. So this is wrong because it is odd function. This is also like only decreasing one side. It is not going to give you this particular like graph, because even if it is like even for mod x, this also not give you because x is odd. Okay, so only this is the option and it will give you the correct solution. So for question number 7 it is option C. Let us talk about question number 8. Which of the following option can be inferred from the given passage? So this question was very good. Like he's saying when I was kid. Okay, so when he was kid, then he did all these things. It means it was a adult's memory of what he or she liked as a kid. So 8 is B. Quickly I'll just tell you, ninth is the option will be 700. I'll tell you how. It is very easy question. It won't take more than 10 seconds to solve. So ninth is C, ninth is A. Question number 10, if you solve, you can just fold a paper and you can see. So it will come up like C 31. Okay, so ninth is C, 10th is C. Then question number 11, that is very good question. This is again going to give you C 2 by 7. Okay, so quickly you can match your answers. If you have like question number 11, the option is C. All right. Question number 12, this is going to give you rate of increase of the scalar function in the direction of this V at point this. So this is a very good question on directional derivative. Okay, so this will give you the answer as B. Okay, so in detailed solution you can just have a look on that, but right now you just need to like cross check your answers. Let omega to the power 4 is equal to 16j. Which of the following cannot be the value? Okay, so this has multiple solutions because I have taught you already in like complex numbers. So any numbers can be represented by e to the power j 2 pi 2n plus 1, or like 2n plus 1 pi by 2, or e to the power j n pi something like that. So we will tell you. So the option that can be there for this is option A, e to the power 2 into e to the power j 2 pi by 8. This cannot be the value. Question number 14 is the value of this contour integral. So this contour integral comes up as option B, pi into 1 plus j. Okay, so pi into 1 plus j is the answer for this. Question number 15, this is a like a question based on eigenvalues and eigenvectors of the matrices. So the option for this is option D. Then in a semiconductor of Fermi energy level lies in the conduction band, right? So you guys already know that this is my conduction band and this is my valence band, and let's say this is my like intrinsic like energy level. The Fermi level goes upper for n type, like let's say it is here, so it is like Fermi level n type, but he is saying that semiconductor will be what type when Fermi energy level is inside the conduction band. So this conduction band actually has gone inside it. Okay, so it has entered inside that, so that actually makes still n type, but it will be degenerate type. Okay, so it will get degenerated. So the option for this 16 will be option A. Okay, so it is still n type but it will degenerated. Question number 7 is question number 17 is for an intrinsic semiconductor at temperature T equal to 0 Kelvin. So see, intrinsic semiconductors at 0 Kelvin becomes insulator. Okay, so if it is insulator, what will happen? There will not be any I mean electrons in the conduction band. So what would be the option? The option that has no electrons in the conduction band and all the electrons are there in the valence band. Okay, So that will be 17 is option A. Okay. Like conduction band are empty of electrons. Okay. Then question number 18 is, in a RLC circuit has quality factor of this. So this is very easy. I have, I will tell you, it is very easy. 1 by R root under L by C, and omega will be 1 by root LC. So using these two relations, I will tell you the option will come up as D. Okay. So right now you write it down. I will tell you in the detailed solution how it is. This is a very good question. I have taught you guys in electronic devices. So it is saying that VFB and VT are flat band voltage and threshold voltage. The variation of depletion width, okay, that will be how. So before this VFB there will not be any there will not be any depletion width. So C is anywhere wrong. Okay. So it will be varying slowly, and then after VT, after threshold voltage, it will become constant. So that is going to give you only option B. Okay, so 19 is B. B for Bombay. Next, question number 20. Question number 20 is very, very, a good question, and there are some of the, people that are getting it mistaken. So the option that you will get is for 20, you will get it as D, like both Vp will be less than C as well as Vg will also be less than C. Why? Because your velocity in the medium will be C by root under mu epsilon, and from here you are going to get C by 2. Okay, so anyway Vp is lesser than that, but Vg will be in that case more than V, but still it will be lesser than C because V is already half of C. Okay. Question number 21. It is a question of whether it is which kind of source. So these two MOSFETs, I will tell you how it will come. However, it will come up as current controlled current source. Okay, so 21 is D. Question number 22. This is actually like a little different question, and I think it is going to be a like a wrong question. Let the IITian comes up on this. So a cascade of like common source amplifiers in a unity gain feedback configuration oscillates when. So common source amplifier in a unity gain feedback oscillates. So none of the options were actually matching. Okay, none of the options are correct. So I think like you all will get marks in this particular question. So marks to all. Okay, I have given you the complete explanation for this particular scenario in the detailed solution. Okay, so that is fine. Next, question number 23. In the circuit given below, P, Q are the inputs. The logical function realized by the circuit is. So this is mux. It is so easy question. You have already like y is equal to how much? This is select line. This is I node I1. So I had told you earlier. So it takes just a second to like solve this particular question. What is that? Q bar into first input I naught plus Q into second input I1. So I naught is 0, so this is gone. Q into I1 is P, so this is simply PQ. So PQ is the answer. Okay, so question number 23 is A. Okay, moving to next question number 24. So 24, what will happen is you will get the answer the latency will be 3 nanosecond as well as the throughput will come up as 1000 megabits per second. Okay, so why it is coming 3 nanosecond? Because like 1 gigahertz, so that is going to give me 1 nanosecond time, because t is equal to 1 by f, that will be 1 by 10 to the power 9, that is 1 nanosecond. So since 1 2 3, so after third thing, it will come up this bit. So the total latency, the total that will come up as 3 nanosecond. Okay, 1 plus 1 plus 1, that is 3 nanosecond. Now what would be the throughput? So the throughput that can be calculated is very simply. So I'll tell you like in the detailed solution. It is very easy. Like you have to just find out after how many seconds it is coming one bit. So one bit is coming in 1 nanosecond time. So that is basically, you know, like in 1 nanosecond you are getting 1 bit. Okay, so in 1 second how many bits you will get? 10 to the power 9 bits. Okay, so in 1 nanosecond you will get 10 to the power 9 bits, sorry, 1 second. So that is nothing but 10 to the power 3 or 1000 megabits per second. Okay, so 1000 megabits per second will be the throughput. So like in 1 second how many bits you are going to get, that is the question. Okay, so option A for 24. 25 is the open loop transfer function of the unity negative feedback system is this, the phase crossover frequency. So this formula directly I have given you, you know, like this is the questions that I have solved directly in the class, and you have got this kind of question. So 25 is going to come up as 1 by root under T1 T2. Okay, then consider a system with input. So the system is what? Since I have not taught you signal system, however, you know, like I mean, this question was very easy. The 26 that you are going to get is, it is non-causal but time varying. Why time varying? Because it depends on time, x into e to the power t. Next, 27, the answer that is going to come up as option B, e by 2. 28, the Fourier transform x of omega of x of t is equal to e to the power t square minus t square is equal to. A very simple question. You can see the beauty is they have given you the value of this particular integration also, so you could have directly got this particular answer, and that would have come up as how much? So 28 is option C. Okay, next is 29. So you know, like this is very simple question. Again, like you have signal type and you have a spectral characteristics. So continuous, aperiodic, what is the kind of this thing? So the option that you will get for 29 is option B. Then coming to question number 30. So question number 30 going to get is, for a real signal which of the following is our valid power spectral density or densities? So which one of them will be valid? You have to find out that the integration must be coming up as 1. So for that it will be coming as, you know, like first one A as well as B. Okay, both will come for this, because here it is coming up 0, here it is, you know, like again something different. So none of them are valid, and the values are not also given, so you cannot calculate them, but this will be coming 1 1. Coming to question number 31. So 31 you are going to get this solution as, the resolution of this is very easy. How will you get? Like SNR in PCM I have taught you, what was that? 6n plus 1.76 or 1.76 plus 6n. So that will be equated to 61.96. So from here you will get number of bits as 10 bits. Okay, so the answer for 31 is 10 bit. Question number 32. In the circuit shown below, the current I flowing through 200 ohm is. So this is again very simple question. You can, if you want, you can directly put a, you know, like a node equation here and find out, or otherwise what you will do is you can, you know, like convert these two particular, you know, like things in source transformation as well as these two, and then you can solve it. I have solved it in detailed solution, so you will have the answer for 31 as 32 as 1.36, okay, milliampere. So you have to write down 1.36. Question number 33. 33 is going to give you the value, the maximum power transfer will be 80. Okay, So the answer for this is going to come up as 80. Coming to question number 34. So this is again a like propagation delay type of question, and I have taught you very clearly the I mean flip-flop topic. So this is kind of a latch. So this latch is going to give you what is the yeah, this latch is going to give you the critical path delay in the nanosecond will be 2 nanosecond. Okay, so you have to write the answer as 2. 35. 35 is very simple question where you have to like utilize the uh, I mean first order circuits kind of concepts. So in this, the answer that will come up as 4. Question number 36. So question number 36 is going to give you this a random variable x distributed normally as n equal to 0 to 1. Okay, so if you have you will get the solution as question number 36 ka B. Okay, because you have to just like construct this. Okay, so the form of probability density function of y. So this is my like distribution function, and we have to find out the probability density function of y. So that will come up as B. Coming to question number 36, sorry 37. So 37 is going to give you the value. This is very simple question. I have taught you this kind of questions in uh, even electromagnetics as well. Okay, so in electromagnetics also I have taught you this kind of integrals. Anyway, this can be solved in mathematics as well. So the question that you are going, I mean the solution that you are going to get for this is option B, 24. For the question number 38, the value that you are going to get is option A, which is L square. Okay, the question number 39 is very simple question. You have to just apply your mind and find out what is your like let's say VO1 at this point, what is the VO2 at this point. Then this is kind of like a normal summer. So V out can be simply like negative of this VO1 plus VO2. Okay, so this is how you can find out. So this is very easy question. Okay, I have solved it in detailed solution. So the answer that you will get for this particular question 39 is option A, minus R4 by R3. Question number 40, you will have the solution for question number 40. This question is option A. This is the transfer characteristics. So I have like spent quite lot of time, and I have given you around like some more than 10 question and with different configurations how to find the transfer characteristics of diode like circuits. So the option A is the answer for this. Then coming to question number 31. So 31, the question the solution that you will get is, sorry, 41, the solution that you are going to get is question number 41. It is going to come up as option A. Then question number 42, you are going to get the very simple question. You can directly apply the Mason's gain formula, which was very like sounding and very promising as well. You don't have to apply like block reduction technique. That is nonsense. Okay, so by that you could have got in 1 second what was the answer for this particular question. That is 42 is option A. Okay, then question number 43, the solution that you will get for this is again option A. Question number 44, S1 was closed and S2 was open for long time, so accordingly this is again like a question on like I mean transients. So that kind of questions again I have solved many questions. So the answer for this 44 question is Question number 44 you will get -1, that is B for Bombay. So guys, I think you would have like I mean found out average question. It is not very tough, as well as it's not very easy also. So I cannot like promise. According to my understanding, the first ranker may get around 80 to 84 marks, not more than that at all. Okay, so that's the scenario that I have come across from the question label. Question number 45. 45 question number, you are going to get the solution for 45 is option B, 3 by 2 BT. Okay, Bombay, B for Bombay for 45. Question number 46, you will get this two port network. Two port network I have spent a lot of time, and you could have solved it very easily. So question number 46 you are going to get, but the problem that I found out here is they have mistaken a little, and you will not have any of the option proper. So you are going to get all of you marks to all. Let's see how like IIT decides about it, or we will like apply our more mind in this. Okay. So question number 46 again is marks to all according to me. Still I am open for like a new discussion on this. So question number 47, you are going to get option 47 as option A. Okay, A for Ahmedabad. Now coming to question number 48. So 48 is the solution for 48 is option C. A very simple question. You could have directly like put it output what is the Fourier transform of this particular series or this particular like signal. Then question number 49, the option that you will get for 49 is option A. Okay, 15W by 4 cos 10.5 WT. Okay, then coming to question number 50. So question number 50 that you are going to get is the question number 50 that you are going to get is how much that option is D for this. So you would have seen this is very simple question in like communication system, and I have taught you guys how this particular signal gets multiplied, and here it is added, and you have the required sample weight of T is what. So question number 50 is option D. Then coming to question number 51. So 51 is going to come up as the S parameter of this port network, and we had to find out the S parameter of the resultant two port network. So that will come up as, it is bit tough question, but I have solved it in like in detailed solution, and you'll get it as option A. Then coming to question number 52. 52 question number is the standing wave ratio. So this kind of questions also I have solved directly in the classes. So I think like communication and EMT, none of the question you would have left till now we have got it. Any question that you could have solved very easily. Okay, as well as control system and network theory and AEC question like analog electronics question, EDC questions. Okay, DLD questions were very easy, directly one shot like you could have I mean very easily written. So for the question number 52 you are going to get two options. One will be option B and another one will be option C. Okay, so these are like multiple choice. Then question number 53, I have taught you how to find out the like elliptical polarization and whether it is left hand or right handed. So this is very simple question. Okay, and the option that you will get for this 53 is A, B and D, A, B and D. Okay, so this is how you can find out. Then coming to question number 54. So 54, the following circuits represent lumped element equivalent of an infinitely small section of a transmission line. So this one you are going to get, I have like separated it in the class directly, and you could have seen that the option that are valid is again, like A is a element, so looking something like that. No, not A, sorry, A is not that, but the option B is looking like that, okay. And option D is looking like that, okay. So option B and option D are this thing. So just mark it like question number 54. The options for these are option B and option D, okay. Coming to the question number 55. So question number 55 that you are going to get value for this is very simple. It was 0. So 55 you will get 0. Let us see question number 56. Okay, so the 56 question number that you are going to get is 2.25. So answer for this is 2.25, and the value for 57 number of question is question number 57. The solution that you will get for A plus B plus C, it is so simple. You could write by yourself, okay. You could write it by yourself. How will you write? uh, like A is, like a zero, and B and C are the poles, right? So as you can see, uh, A plus B plus C, what it should come? So first it is going to come up as what is that? A pole 20 dB. So B is actually 1, okay. So B is 1. Then it is going to come up again up, so means A will be again 1, okay. And then C will be coming up minus 40 dB, so 2. So that is totally how much it is? uh, Totally it is coming up as 1 plus 1 plus 2, that is 4. So the solution that will come up as A plus B plus C is 4. The question number 58, the solution for this will be 15. So I'll tell you how, okay. Then question number 59, that will come up as 0.2 0.59, okay. So 0.59 is the solution for question number 59. Sorry, not 59. The question number 59, the value that you will get for this is 0.25. This is average power that we have to find out. It's very easy question. Then question number 60, the value that you will get is question number 60, that value will get is let us see that. So the question number 60 that you are going to get, the value is 0.133, 0.133, okay. And the question number 61, the answer that you will be getting is 63.36, okay. Coming to question number 62. So 62 is actually again a problematic question. They have missed out some information. So I am expecting that marks to all will be given for this as well. So till now we have come across three questions which are having some problem, and I'm expecting all these three questions will be marks to all. Out of that, two questions are 2 marks and one question is of 1 mark, so total 5 marks you are going to get just like that. All right. So question number 63. 63 is very good question. You have the initial state and you have to find out what is the frequency. So you what will you do? Clock frequency is given, right? So if clock frequency is given, then you have to just find out what is the mod number for this particular timer, a particular counter, and this particular counter will give you a time, like mod number. So you divide that by 1 megahertz divided by that, so you are going to get it as 250 kilohertz, okay. So the mod number that you will get is 4. Then question number 64 is 2, okay. So the circuit, the voltage VL is actually 2 volt. So this also I have taught you, like in RAM RAM constructions. Then question number 65 that you are going to get is, so the question number 65, the answer is going to be 1.984. So I hope you could find out it, like a little useful. So thank you guys. You try to match your answers with all the questions, answer key that I have given you. So this was the solution for ECE. I'll be coming up, with the answer key for electrical engineering as well as instrumentation engineering soon. So the thing is, like, I am solving all the questions on my own single-handedly. So let's see how does it go, and I'll give you the detailed solution during the class, as well as soon we will be giving you the detailed solution for all the questions. Thank you guys. Enjoy your day.